Okay, let's dive into this. Hello, everyone, and welcome to This Explainer. If you've ever looked up at the night sky and felt a sudden wave of awe, or, maybe just a little bit of existential dread, you are in exactly the right place. Today, we're jumping into a really fun education lesson, all about our place in the cosmos. We're going to discover the true scale of space, starting from our everyday lives and stretching all the way to the very limits of what human beings can actually comprehend. So, does the universe even have an end? It's honestly one of the most profound questions we can possibly ask. Over the next few minutes, I'm going to take you on a little journey. We'll start right here at the everyday human scale and zoom out layer by layer all the way to the absolute edge of the observable cosmos. By the end of this, I promise you, your perspective on our reality is going to be completely transformed. Here's a quick roadmap for today. We'll start with number 1, our tiny planet. Then move to 2, the galactic neighborhood. From there, it's 3 trillions of galaxies, before hitting 4, the observable universe. And finally, number 5, is there an edge? Let's start right at home with section 1, our tiny planet. We live on Earth, which is about 12,742 kilometers wide. Now, that feels huge to us, right? Especially when we're flying across oceans and continents. But in the grand theater of space, it is unimaginably tiny. Picture holding a tiny peppercorn in the palm of your hand. That little dot? That's Earth. Now, if Earth were that peppercorn, our sun would be a massive basketball. But get this, they wouldn't be sitting right next to each other. To make the scale physically accurate, you'd have to place that basketball a full 26 meters away from your peppercorn. When you visualize it like that, Earth instantly becomes almost invisible. And the math behind this size difference, it really delivers an emotional punch. 1.3 million. That's the number of Earths that could fit completely inside the volume of our sun. Over 1 million of our planets just swallowed up by a single star. And that sun anchors our entire solar system, holding 8 planets, hundreds of moons, and millions of asteroids and comets. The furthest recognized boundary of our solar system is this region of icy bodies called the Oort cloud. And that boundary extends outward for an astonishing distance of almost 2 light-years from the sun. Let's move to section 2 and see how this builds. The galactic neighborhood, the Milky Way. Now, before we tackle the mind-bending galactic distances ahead, we really need to clearly define our metric here. A light year is the distance light travels in 1 Earth year. And light doesn't dilly-dally. It moves at a blistering speed of 300,000 kilometers every single second. That is literally the ultimate speed limit of the cosmos. Our Milky Way galaxy is home to hundreds of billions of stars. With that blistering speed of light in mind, 100,000 years. If you were zooming through space at 300,000 kilometers per second, it would still take you 100,000 years just to cross from one side of our galaxy to the other. That really emphasizes the sheer enormity of just our local galactic home. Zooming out even further, let's hit section 3, trillions of galaxies beyond the Milky Way. Scientists used to think there were only a few billion galaxies, but newer observations suggest there are likely hundreds of billions, or possibly even trillions. And each of those contains billions of their own stars, many potentially harboring planets, oceans, and atmospheres. Think about this mind-blowing fact. The stars in the universe outnumber all the grains of sand on Earth's beaches. Seriously, let that sink in for a second. Scoop up a handful of sand next time you're at the beach and think about how many thousands of tiny grains are just in your palm. Then think of every beach on every coastline across the entire globe. There are more stars up there than all of those grains of sand combined. Which brings us to section 4, the observable universe, the limits of light. Because light travels at a limited speed, we can only observe places whose light has actually had enough time to reach us. Now, what's really interesting about this is the glaring mathematical discrepancy it creates. The age of the universe is 13.8 billion years old, but the observable diameter? That is 93 billion light-years across. Which leads us directly to a mind-bending paradox. How on Earth can a 13.8 billion-year-old universe be 93 billion light-years wide? If light has only been traveling for 13.8 billion years, shouldn't the observable universe only have a radius of 13.8 billion light-years? How did things get so incredibly far away? It's a brilliant question, and the answer completely changes how we think about the fabric of reality itself. To resolve this paradox, let's walk step by step through an expanding balloon analogy. Imagine you take an uninflated balloon and you draw little dots all over it. Those dots are our galaxies. Now inflate the balloon. As it gets bigger, the dots move further apart from each other, right? But they aren't actually sliding across the rubber surface of the balloon. The rubber itself, the space between them, is stretching. This is exactly what's happening in our universe. Space itself is expanding. So while light is traveling toward us, the very fabric of the universe just keeps stretching out, pushing distant galaxies much, much farther away than their light travel time alone would suggest. Finally, Section 5, is there an edge? The great unknown. We know the observable universe is 93 billion light-years across. But what actually lies beyond that boundary? If space is stretching, does it stretch into something else? Does it just stop? Well, scientists don't know for absolute sure, but they do have several competing theories. The first possibility is that the universe is just infinite, stretching outward forever without end, containing an infinite number of galaxies. The second possibility is that it's curved. Think of it kind of like the continuous surface of a giant 3D sphere. You could travel in one direction forever and eventually just end up right back where you started, never finding an edge. The third theory points to unobservable regions. Basically, there's simply more universe out there, exactly like ours, but it's so far beyond what light can ever reach that it'll forever remain hidden from our view. Space just continues on. So the crucial point is this. We have every problem, every city, every mountain, and every human being in history living on one tiny, fragile planet. And we're comparing that against a universe so vast, our brains literally struggle to imagine the math. When you take this step back and look at the astronomical scale of reality, it grounds you. It provides this profound perspective that reminds us just how precious, unique, and vital our tiny home really is. We've scaled all the way up from a peppercorn to 93 billion light-years of expanding space. We know what we can see, but beyond that observable limit, the cosmos may just continue forever. It remains humanity's absolute greatest mystery. I want to leave you with a final provocative thought to chew on. If you could visit any place in the universe, where would you go? Think about it. Keep questioning, keep learning, and as always, thank you so much for joining me on this explainer. Keep exploring.